Okay. Now let's continue to finish the one-dimensional random walk with one absorbing state and two absorbing states today. Okay. So before we continue the discussion, let's review what we have discussed in the previous class. So there was a drunken man who wandered far too close to the cliff. From where he stands, one step forward will send the drunk man over the edge, and he takes random steps either towards or away from the cliff. At any step, his probability of taking a step away is 2/3, and a step towards the cliff is 1/3. What is his chance of escaping the cliff? So this guy is drunk. He has a probability P to go away from the cliff, and the probability 1 minus P towards the cliff. And here, this is the absorbing state. Once you are here, you will not be able to escape. Okay? So P and 1 minus P is always the same at different locations. Okay. Now, what's the probability escaping the cliff? So this is the question we are trying to study in this class. Okay, I was trying to delete the white page, but it seems that we don't need the white page anymore. Now this is a distance from the cliff. This axis is the distance from the cliff, and this is steps taken. Okay, he can take one step. You see, he reached the absorbing state in 1 step, 3 step, and 5 step. Many of the cases it's odd number, right? Odd number of steps got absorbed, and even you cannot get absorbed. Okay, so this is 1 step, and 1, 2, 3, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, and we can continue to do this with computers. Okay, and if we were here, the probability to get absorbed towards the cliff is 1/3, and away from the cliff is 2/3. Okay. Now in this case, if we are away from the cliff, so that means we have already taken 1 step, 2/3. Given that we take the first step in this way, then what's the probability we take another step, the second step here, and then another step over here? So this will be 1/3 times 2/3. And 2/3 times 2/3 again. Okay. And last time we had a question about why this is 427, because you have a probability over here and you have probability here. Why don't we add them together? Is that your question? Okay. That is because there is only one possibility. You cannot do this and do this at the same time. Okay. They cannot jointly happen at the same time. You can only either choose this or either choose this. Okay? Okay, they cannot happen simultaneously. So if you take 2 steps, given the first step, given the second step, you are here, 2/9, and then you have take 1 more step, then this is 1/3, 2/3 again. Okay? This is how we derive this those steps. Okay? And the probability, what's the probability to get absorbed? This is the probability to get absorbed, and this will get absorbed, and this will get absorbed too. So it's not just you are standing here, it's not that you get absorbed, it's only 1/3. There's still some other probability this person, this drunken man, will get absorbed. Make sense? Okay. But based on our observation, only odd number of steps this guy can get absorbed. And even steps he will not be able to get absorbed. Okay, very good. Now let's derive. This is just an illustration. Now let's calculate what's the probability to get absorbed at step, maybe at number of steps at step I. So let me make sure it's more clear. Let me write it down. Let's denote Pi to be the probability of absorbing given starts at I. You see, if you start at 2, distance from the cliff 2, what's the probability to get absorbed? If you start at 3, what's the probability to get absorbed? This I denotes the distance or number of steps from the cliff. Or this I denotes where you are. You could be here or you could be here. So what's the probability of P1? So what is P1? P1 is actually, this is a subscript. What is P1? Actually, what does P1 stand for? P1 stands for this drunk man has one step away from the cliff. What's the probability he will get absorbed? What's the probability of absorbing, given that he's one step away? So this is a cliff, right? So one step away. So this, what does this depend on? This actually depends on P. And this P is lowercase p. This lowercase p is actually the probability the person go left or go right. This lowercase p is right here. It's right here. The probability to go right and the probability to go left. It depends on the p. Obviously, it depends on the p. But what is the relationship between P1 and this lowercase p? So if I may draw it, I can draw a cliff over here. You see? So this is 0, and this is 1, this is 2, and we have -1 and +1. And to the right away is P. This is 1 minus P. Okay. And this is the absorbing state. This is the starting location. Obviously here we are trying to say the starting location is 1. He starts at 1. Start at 1. Now, P is taking 1 step away, and 1 minus P from the cliff is taking 1 step towards the cliff. So this P1 will equals to, what is P1? P1 is actually absorbing. Eventually, this person get absorbed. When we define this eventually this guy get absorbed, start at a location I. So this is location 1. Okay? And if we start at location 1, we have a probability to go right, and we have a probability to go left. So given the person go to right, given the person, so we have conditional probability here. Right? So this one will be given the person goes to the left. If it goes to the left, then 1 minus P should be times So P is going to 1 minus P goes to the left, right? And the plus should times something, right? Times what's the probability to get absorbed? Plus P times something. So total probability, given that goes to the left, what's the probability of absorbing? Goes to the left. 1. It gets absorbed immediately. And what's the probability? If it goes to the right, what's the probability of absorbing? It still can get absorbed. Because if you go here, and you can wander back, and then you can wander here, and then come back, right? This is not 0, but this is actually, when you start at a 2, location 2, get absorbed. So then we have the recursive relationship. Now, because this is location 2, right? If you take a step away from location 1 right here, then we just take this as a start. Then we see what's the probability this guy get absorbed. So this is the probability for this person get absorbed given he's in location 2, that is P2. Actually, this is definition, right? Start at location I, get absorbed. So what is this part? This part means goes to the left, okay? And at step 1, this part is goes to the right. And if the person goes to the right, this is absorbing later. This is absorbing right away, right? Okay? So why do we have this? This is because of the probability A is equals to probability A given B times probability B plus probability A given B complement times B complement. So we only have 2 possibilities at 1. But in order to solve for P1, now our question is, what is P1? What is P1? Okay. If you can see, what is P1? We want to get a P1. So how do we get a P1? Obviously, if we know P2, we get a P1 immediately, right? But obviously, we need to solve for P2. So what is P2? Now, what is P2? Let's analyze if the person is in the step is right here. If the person is right here, then what are we going to get? So absorbing at the starting location is 2, actually can be broken into 2 parts. What are the first part? First part, obviously, that is the path that goes from x equals to 2 to x equals to 1. If you start at location 2, you still have 2 possibilities. You go left or right. So one path goes from x equals to 2 to x equals to 1. This is for the first time. Not necessarily in one step. And the second one is a path that goes from x equals to 1 to x equals to 0. Again, not necessarily in one step. So there are two parts. The first part is if we start in location 2, if we start over here, obviously we can wander here, right? And then maybe we go back to 1 for the first time. Okay? And if we want to start, it goes from 2 to 1 for the first time, and you can go from here and then come here, right? Okay? And it's like 1 is absorbing. If you go from here for the first time, you got absorbed. And if you go here, 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 and then you got absorbed, that's still for the first time. Why we add for the first time? Because we are treating 1 as the absorbing state. Okay? For the first time. And once we reach 1, it becomes to be P1. Right? Is this P1? From x to 1, not necessarily in the one step. You can go left or go right, but not necessarily in one step. This person get absorbed. This is P1. This is exactly what our definition. Absorbing, start at 1 and then get absorbed, not necessarily in one step. So this is P1. And if we go from location 2 to 1 for the first time, we're treating, because we have for the first time, we're treating 1 as the absorbing state. It's still P1. We're just treating location 1 as the cliff. Right? When you are in location 1, location 0 is your cliff. Okay? Then once you reach the cliff, and then you have another one. But for location 2, once you reach 1, and then you have P1, one more P1 to go. So now let me write it down. So the first one, this one, this is actually P1. This is P1. This is obvious because this is definition. You go from location 1 to 0. Why this is P1? Because the structure here is identical with that of the original setup for the particle. Except that the origin has been translated one step to the right. So basically the idea is the cliff, if we, this problem, the setup is almost the same. It's just that we are shifting the cliff one step to the right. The origin is 0, where x equals to 0. The origin is shifted just one step to the right. So this is P1, this is P1, and you have 2 steps to take. When the Drunken man start at a location 2, he has 2 steps to take. So the P2 is actually P1 squared. P2 is actually equals to P1 squared. This P2 equals to P1 squared, so which equals to P1 squared. Okay, now it's much easier for us. Now we have P1 equals to 1 minus P and times 1 plus P times P1 squared. Therefore, we have this formula because this is P2, so P2 is P1 squared. Then we solve this equation. So what do we get? This is actually P1 squared minus P1 plus 1 minus P equals to 0. So if we solve this equation, what is P1? P1 equals to 1 or 1 minus P over P. So if we look more closely, the real solution is, you see, here, when P equals to 1/2, what is P1? P1 will definitely get absorbed. It's 1 minus P divided by P. Let's try to find 3 locations. P equals to 0, P1 equals to 1, P equals to 1, P1 equals to 0. So if this is P1, this is P, obviously there is a place called 1/2, there is a place called 1, and the solution is actually like this. I didn't draw this very good. Let me try it well. Okay, it's right here. So this, where is this location? P equals to 1/2. This is 1. P equals to 0. P1. Oh, P equals to 0 right here. 0 right here. This is this location. And also P equals to 1. P1 equals to 0. So where is this? So this equation is actually P1 equals to 1 if P less than or equals to 1/2. And P1 equals to 1 minus P and over P if P greater than or equals to 1/2. So the solution for P1 is actually is 1 if P less than 1/2, and it will equals to 1 minus P over P if P greater than 1/2. Now suppose P equals to maybe 2/3. So what if P equals to 2/3? What is P1? Omar?
1/3 divided by 2/3. That's 1/2.
Yes, this is 1/2. So what does this mean? Or how do we interpret this figure? That means if the drunk man, okay, if the drunk man has half probability to go left, half probability to go to the left, he will definitely get absorbed. What does it mean, get absorbed? Fall off the cliff. He will definitely. And if we want this drunk man to have 50% of probability to survive, then his probability to go P is go right. Go away from the cliff should be at least 2/3. Okay? That means go to the right should be 2/3. A higher probability to go 2/3, then he still has half probability, 50% to get absorbed later. If we want to increase the probability, he go right should be more than 2/3. If we wanted the probability to escape the cliff greater than 50%. Yeah, more than 2/3, right? Okay. Now, what happened to PI? what about starting at I and the pi? So pi is actually equals to 1 minus p over p and power I if p greater than 1/2. And it is 1 if p less than or equal to 1/2. So up to now, this is P1 and this is Pi.